right, so I'm going to go ahead and explain how to find a quadratic inverse of a quadratic equation. Um, so the first thing we need to know, to find an inverse, the function has to be a one-to-one and on two. We're going to assume in high school that all the functions are on two, but we are going to have to do a quick check to make sure it's one-to-one. If it's not one-to-one, we're going to have to actually restrict the domain. So let's just take the example of the equation f of x equals x squared. Now, everybody knows that this graph is a parabola that starts at the origin. And of course, my vertex is 0, 0. This is a function because it passes the vertical line test. So the first thing you need to make sure is it is a function, in fact. So you want to check a vertical line test. And if you put a vertical line anywhere on x squared, it'll only touch it one time, meaning that it's a function. The one-to-one, to see if it's a one-to-one function, instead of doing a vertical line test, we do what's called a horizontal line test. So we actually draw horizontal lines, and it should only touch in one spot. So here, this horizontal line, and every horizontal line is going to touch in two spots, except for right at the vertex. So what we're going to have to do is restrict the domain. The original domain of f of x equals x squared is going to be it's the set of all x's such that x is an element of the real numbers. This is the domain. So what we're going to have to do is we're going to have to restrict this somehow. Really, the best way to do that is we do a little trick in math. And the trick that we do is we just kind of cut it, or we pretend part of it doesn't exist. So we just forget like half. We forget half of it. So we erase it, pretend that that half doesn't exist. So we just have this part right here. And now we say, you know what? Instead of saying it's every possible x value, we now restrict the domain as the set of all x's. And x, of course, is still an element of the real numbers. And x has to be greater than or equal to 0. Now, the beauty of this is we could cut it different ways. I could have cut it the other way and actually wrote a domain as a set of x's, set of all x's such that x is the element of the real numbers. And in this case, x could be less than or equal to 0. Both of those cuts work. This one right here is the one that you will see over and over and over again. This one is more of a novelty. But definitely pay attention to it because you know I'm going to kind of trick you up on tests and everything else. But as far as if I don't tell, I'm 99% of the time it's going to be this domain restriction. Outside of my class, it's probably going to be the domain restriction 100% of the time. Of course, with any inverse, we also know that when we find the inverse, domain and range interchange. So I'm now going to show you how to actually find the inverse of a quadratic equation. They are considerably more difficult to find the inverse of than a linear equation. Here, I'm sorry, I kind of cut it off up top. I wrote it a little high, but it's f of x equals x squared plus 4x minus 9. The steps is what we were finding earlier to find the linear equation are the same. We're going to change f of x to y. So let's do that now. Y equals x squared plus 4x minus 9. And then from there, we are going to interchange the x and the y's. We're going to swap them out. So this y becomes my x, and all these x's become a y. So I get y squared plus 4y minus 9. And now this is where the fun algebra actually begins. We're going to have to solve for y. So we're going to have to do a couple of creative things. One thing you are going to have to be able to do is completing the square. We did an activity in class. If you've forgotten how to do it, you can actually go to the basic math videos folder in Schoology because I have 4 different videos in there explaining how to complete the square. There's different scenarios. This is a pretty straightforward scenario here. So the first thing I'm going to do is I'm going to get all my y's on one side. Anything that doesn't have a y, I'm going to put it to the other side. So I'm going to add 9 to both sides. So I'm going to get x plus 9 equals y squared plus 4y. Now I want to complete the square on this side. So if you remember, we had to take our middle term b here, 4. We're going to divide it by 2, which gives me 2, and then I'm going to square it, which gives me 4 back. I know it's the same number back. It's just coincidental. It's pretty with 4s and 1s. But always go through this exact same procedure. Um, Now here, I'm going to have to add this 4 to this side. Now the rules of algebra state what you do to one side of the equation, you have to do to the other. So I'm going to do x plus 9 plus 4 because I'm going to add 4 to the other side of the equation, which gives me y squared plus 4y plus 4. This makes a perfect square trinomial which factors, so let's clean this up. And I have x plus 13 equals y plus 2 squared. Here, now we're just going to solve for y. We're going to take the square root. Always remember to do the plus or minus. So here we're going to do plus or minus the square root of x plus 13 equals y plus 2. I subtract 2 from both sides, and I get negative 2 plus or minus the square root of x plus 13 equals y. Now, up here, I didn't write a domain on this. But let's say if I said x had to be greater than or equal to 0. So now I'm going to actually look and say, all right, I've got my plus or minus. And what numbers are greater than 0? Well, those clearly are going to be my positives. So with this domain restriction, the inverse, I'm going to rewrite this in inverse notation, is going to be f inverse of x equals negative 2 plus, we don't need the minus because a minus would not make this a true statement, the square root of x plus 13. And that is your inverse.